Good day everyone, this is Mrs. Venti. Welcome back to my channel. Today we are going to start trigonometry with a basic introductory course. I'm using the Mind Action Series textbook for grade 10. I'm going to be on page 160 up until 162. In this video I'm going to look at the examples 1, 2, 3 and 4. Before we get started, can I ask you to please like and subscribe so that you get notifications of all future videos and everything is on your page. Right, let's get started. The first thing that you need to know when it comes to trigonometry is that trigonometry has to do with the relationships between angles, with angles, and between sides. So before we can use trigonometric ratios, you need to know the names of elements of a triangle. In the triangle that we have on the screen, you have a 90-degree angle. The square on the bottom right hand side means that this is 90 degrees. You are familiar with this because we used this in Pythagoras last year. You also know that the line opposite the 90 degrees angle is called the hypotenuse. On the top, so this triangle is called ABC. On the top we have angle A. Angle A has got a special symbol. It looks like this. This is a Greek letter and it is called theta. Angle theta. When we name our angles in trigonometry, we use Greek lettering. So you will see theta, you will see alpha, and you will see beta. Those are different ways of naming the angles that we will be working with. Now, moving from here, you need to understand that the names of the other two sides is in relation to angle A or angle theta. So, angle theta has got two legs, right? The side that is part of angle theta, namely this side, is called the adjacent side. Adjacent also means next to. So the side that is right next to theta, in other words, one of the legs of theta forms that side, is called the adjacent side. And then the one that is opposite theta is called the opposite side. Now, why are these words important? You ask a good question. In trigonometry, we work with three trigonometric ratios. The three ratios are called sine, cosine, and tangent. Now, the sine ratio refers specifically to when we speak about sine, we speak about sine in relation to the angle. So we are going to talk about sine of theta or sine theta. We do not write the full word, we write only the first three letters, but we express it as the full word. Sine of theta is going to be the ratio of opposite over hypotenuse. And this is where you immediately see why we identify adjacent, opposite, and hypotenuse. So for me to work out the sine of theta, I am going to take the opposite angle and I divide it by the opposite side, and I divide it by the hypotenuse side. That gives me the sine of theta. The cosine of theta is known as cos of theta, and cos of theta is adjacent over hypotenuse. So again, I'm going to take the adjacent and divide it by the hypotenuse length. And then lastly, I have got the tangent, which is known as tan of theta, which is known as opposite over adjacent. So the opposite side divided by the adjacent side gives me the value of tan of theta. Now, what is very important that I didn't do is you must always have your degrees sign when you are drawing or writing referring to an angle. These are the ratios that we are going to use in the rest of trigonometry. So these are the three, and we are also going to do reciprocal ratios, bringing it up to a total of 6 ratios. But today we're only using 3. Let's get started with example 1. In example 1, we have the triangle ABC, where angle A is 60 degrees and angle B is 90 degrees. We have the length of AB equaling 1 unit, BC is the square root of 3 units, and AC is 2 units long. In this question, they are asking us to calculate sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. In order to do this, you need to identify the hypotenuse, opposite, and adjacent. Since this is my 60 degrees, the leg that goes with the 60 degrees is known as my adjacent side. The one opposite is known as the opposite side. And the long one that is opposite the 90 degrees is known as the hypotenuse. Once I've identified the sides of my triangle, I can now complete and answer these questions. So sine of 60, going back to my original, so these trigonometric ratios you have to memorize. You need to know them off by heart. Sine is opposite over hypotenuse. So I'm going to write opposite over hypotenuse, and then I can substitute the values where I say opposite is square root of 3 over hypotenuse is 2. I cannot simplify that any further, and therefore that is my final answer. Cos or cosine of 60 degrees. Cos is adjacent over hypotenuse, so cos is going to be adjacent, which is, let's first write it out, it's adjacent over hypotenuse, which is 1 over 2. So cos of 60 degrees is a half. And then lastly, tan of 60 degrees is going to be equal to opposite over adjacent. My opposite of 60 is square root of 3, and my adjacent is 1. So square root of 3 over 1 is equal to the square root of 3. That is how you answer example 1. In example 2, I have triangle LMN, where angle M is equal to theta degrees, angle N is 90 degrees, and side MN is 4 centimeters, side LN is 3 centimeters. Now the question in this section is asking me A, what is tan of theta? Now based on previous knowledge, information that we've memorized, we know that tan of theta is opposite over adjacent. Now I start with theta and I say opposite is going to be 3 centimeters and adjacent is going to be 4 centimeters. So tan of theta is going to be 3 over 4. Question B says to me, what is cos of theta? I know that cos of theta is adjacent over hypotenuse. I know that adjacent is 4 centimeters, but in this instance, I do not know what the hypotenuse is. In order to answer this question, I need to figure out what is hypotenuse. How can we do this? We are going to use the theorem of Pythagoras. Now, according to Pythagoras, if you have a 90-degree angle triangle, then you can apply the theorem of Pythagoras. And Pythagoras says that side squared plus side squared is equal to hypotenuse squared. So the word hypotenuse is the same whether you are using Pythagoras or whether you are using trigonometry. It's the same side. So in this instance, mn is going to be our one side, so it's going to be 4 squared plus nl, which is our second side, 3 squared, is equal to hypotenuse squared. 4 squared is 16 plus 3 squared is 9 equals h squared. 9 plus 16 is 25 equals h squared. In order to get h, I am going to square root both sides. So square root of 25 and square root of h squared. This means that h is equal to plus or minus 5. So the long end, ML, is actually 5 centimeters. And I know this because I used Pythagoras. So in answering question B, I now can input 5 centimeters as my denominator. So cos of theta is 4 over 5. The last question is asking me what is sine of theta. Sine of theta, I know, is opposite over hypotenuse. And I know that the opposite of theta is 3 centimeters and the hypotenuse is 5 centimeters. I know this because of the theorem of Pythagoras. So sine of theta is 3 over 5. And that's the answer to example number 2. In example 3, we have triangle TRS or RST. We have angle S as being 90 degrees, and then we have side RS is 12, RT is 13. The first question says, what is cos of T? So this T refers here to angle T. Cos means adjacent over hypotenuse. And when I look at this, adjacent is going to be this line, which is already an unknown. TS is adjacent to T, and I don't know what it is. So again, I am going to use Pythagoras. The theorem of Pythagoras says side square plus side square equals hypotenuse square. So the side that I'm looking for is TS, that is unknown, plus RS is 12 squared is equal to H squared, which is RT, 13 squared. So in order for me to calculate this, I am going to say minus 12 squared on both sides. So S squared is equal to 13 squared minus 12 squared. I hope that makes sense to you. What did I do? I said minus 12 squared on this side, minus 12 squared on this side, and I did that in order to get S squared on one side alone because I am solving for S. So side squared is equal to 169, which is 13 squared, minus 144. And that gives us 25. Side squared is equal to 25. In order to get side alone, I'm going to say square root on both sides. So S is equal to 5. In other words, TS is actually 5 units. Now I can answer my question because I now know that adjacent is equal to 5. So it's 5 over 13, which is my answer there. Next up, sine of T. Sine is opposite over hypotenuse. And my opposite here is going to be 12. 12 over 13. That's my answer for sine of T. And lastly, tan of T is going to be opposite over adjacent. So opposite is going to be 12. And adjacent is 5. 12 over 5 is my answer for tan of T. In example 4, we have got a triangle with the lengths of sides being identified as x, y, and z, we've got one angle that's 90 degrees, one angle is alpha, one angle is beta. So they are asking us to get cos, sine, and tan of alpha, cos, sine, tan of beta. So we can do that. Let's start with the alpha. So cos of alpha is going to be, if this is alpha, I know that cos is adjacent over hypotenuse. In this instance, adjacent is going to be x over hypotenuse is z. Cos of alpha is x over z. Sine of alpha is going to be opposite over hypotenuse, which is going to be y over z. And finally, tan of alpha is going to be opposite over adjacent. And we said opposite is y, adjacent is x, y over x. That is dealing with angle alpha. Now let's do the same for angle beta. Cos of beta is going to be adjacent over hypotenuse, and the one that's adjacent to beta is y. It's y over z. Sine of beta is going to be opposite over hypotenuse, and the opposite here is going to be x over z. And lastly, tan of beta is going to be opposite over hypotenuse, which is going to be x over y. And that is how you answer example 4. So I hope this helped you. We went through it really slow, just how to use the trigonometric ratios after we learned how to name the sides and the angles of the triangle. Again, remember to click the subscribe button, and I'll see you in the next video. Thanks for watching. Bye-bye.